So I'll just keep it in my elbow.
I don't know how it was.
I might be older.
Hi,
Hi.
my name is Sarah Williams. I've been teaching math here at Matt Hood for 15 years. Happy to be here today.
Wow. That was
For the
an
invitation.
introduction.
You have to introduce yourself, you know, it's not that good. So I'm here to talk about the Cantor Set today, which in my undergraduate education was probably the first time that I went, what? And just kept thinking about it. I was sort of stuck on it. And so I figured that, you know, in the context of what might you want to have seen before you see it, the Cantor Set sort of seems like one of those things that if you've seen it before you really need to see it, it might be nice. So it is a surprisingly simple development that has pretty amazing consequences. So, so let's just start with the development. So I'd like you to draw a line.
How long?
About that long. And that line is the closed interval from 0 to 1. And we're going to call that T sub now. Okay. And now I would like you to cut out the middle third of that line. You may either draw a new line and cut it out, or you may work on the line you already have. Your choice.
You didn't take the square root of it. It's a square root of 1 plus f prime squared.
Everybody got T1? So to get T2, cut out the middle third of everything that remains. Okay, so back to T1. What was the endpoint here?
Third.
A third. And this is?
2/3.
Okay, now, it's an important piece of building this, that what you're cutting out is the open middle third. In other words, from 1/3 to 2/3, not including the endpoints. So 1/3 is here, and 2/3 is here. They're not missing, they are there still. Everybody good?
What about 0 and 1?
Well, did you cut them out? They were there to start, right? Yeah. So I totally agree, they're there. Everybody good? Okay, so what does T2 look like? I sort of sketched it. Where's this?
1/9.
1/9. And we cut out the middle open third, so 1/9 is there and 0 is there. Everybody good? This is still 1/3. Who's this?
2/9.
2/9. Has to be right. That makes this 3/9 in disguise. Everybody good? Okay, so these include all of those endpoints, which we could entertain ourselves with indefinitely getting their fraction representation. Everybody good? Questions? Can you draw T3?
Probably nice to use a graph on paper.
Here. No, hold on a second. I have to fix that. Wow.
Those people who started with a longer line are having an easier time with it.
Like, you can't draw this more.
However, I'm fairly convinced that I could rapidly run you out of space no matter who you are, right?
Yeah.
So, no matter how long your initial line was, you take out the middle third, after a few times, it's getting hard. Everybody good? Okay. So, the Cantor set is what's left after you do this forever. So the first question is there anything left? What do you think? Yeah,
I think you're gonna run into the wall eventually.
gonna run into a wall, it's well said.
Tiny little dot.
Tiny
It's gonna
little
be
dot.
infinitely smaller and infinitely smaller.
Can you even give me a dot that's gonna be left? Like what number
Zero.
is definitely still gonna be there? 0, good. Is 0 still gonna be there no matter what we do?
Yes.
Definitely, right? We're cutting out the middle third. Every time there's still distance between that middle third and 0, right? 0's gotta be there.
Well, everything that we have now is still gonna be there always. Every dot that we have up there is always gonna be there.
Okay, so as soon as we determine this endpoint is there, that endpoint can't go away, for the same reason 0 can't go away, right? There's distance between that endpoint and the next middle third, every time. So there's a lot of dots. Are they all endpoints? So, yes, all the endpoints are left. Is there anything other than endpoints that's left?
Yep.
Yeah, like what?
1/4.
A quarter. Let's think about a quarter. All right, let's find a quarter. It's right there. Ready? Okay, where is it here? Is it over here? No, it's not in that hole, right? So it's somewhere around there. Okay, where is it here?
Second.
It's in here?
Yeah.
Is a quarter bigger than 2/9? Are you sure?
Mhm.
Okay, a quarter is 2/8, which is bigger than 2/9, good. Or the decimal expansion, a quarter is 0.25 and 2/9 is
0.222.
0.2222. So a quarter's in here somewhere. How about the next one? I can draw, take out the middle third. Now where's a quarter? So this is still a third, this is still 2/9. Who's that?
4/27.
Some 27ths, right? 7, so this would be
I'm sorry, 7.
6, yeah, 7 27ths.
Yeah.
That one's 8 27ths. Convinced because now that's 9 27ths, right?
Yeah.
So that's a good thing. All right, so where's a quarter? Yes, it is okay to use your calculator.